Hello everyone, I'm Xiao Gang. Now we will start writing our server-side code. When writing server-side code, we need to pay attention to one thing. We don't need to worry about encoding issues here, and we don't need to worry about encoding issues. I'll guide you through handling them later. Because this is Unreal Engine to Unreal Engine communication. Actually, when it sends HTTP, it will automatically transcode for you. So, next we need to consider this encoding issue. First, let's open our server-side code. We will need to do this one thing. We need to ensure these few classes, let's see, ours are empty. Let's copy them over. This kind of thing is usually based on the server side. I hope I can copy them all over. No problem, copy them all over. Okay, this is fine. Let's check this name again. This name, we also need to write it correctly. No problem. Okay, then we bring this request type over. We need to bring all of this request type over. So this is why I told you about these three files. They must maintain absolute independence. That's correct. This is the response. We bring it over, put it here. After bringing it over, we need to compile it here. We ensure there are no issues. Okay, this contains the YouTube. Let's check this YouTube. It's obvious that we wrote YouTube incorrectly, right? Because we said the name was wrong at the time, so we changed the name. Change it in 3 places here. This also needs to be changed. Then we compile again. Okay, good. Let's go back to our object. We'll focus on writing this method. This method is a bit more complex, so we need to write it more carefully. First, let's continue writing here. We mainly add our processing of this data here. It seems we haven't retrieved the data from this request. Now we need to retrieve the data from it. First, we need to check the validity of this thing. Let's preset a response data. What is this? This is the data we send back. The data we send back, we haven't written the struct yet. We need to write this struct into our response body. Okay. The encapsulation approach for this struct is actually the same as when we go backwards. We have encapsulated another server response. Let's change this. Simple response. This place, okay. Then the result it returns, it actually refers to this result. Because the server has ultimate authority, then this result type identifies this response type. This is the result. This is the type. Then distinguish between them. As for its result, actually, look here, okay, we initialize it. The default is failure. Then there is this. The result the server gives you this time. Whether it is a success or a failure, then the result it returns. What is this? Then which request is this response reacting to? Then this is the data we encapsulated, right? Since our check version actually has no data, we can just ignore it for now. Once this part is written, we need to call one side. This is a bit nested. We come back to our client side again. It's very nested back and forth here. We must maintain consistency on both ends. Okay, after viewing this, we'll leave it aside. Let's go back to our object here. And here, let's change the name. The ladian here can be removed. We borrow the response data from the server. After the server response, let's first set up a default data. So first, we need to determine whether this thing is valid. Whether we are valid, but we haven't written it yet. Because our check token hasn't been written yet. And here, this inquest is it. Then this check token. Let's write it out first. Let's write it into this public. Okay. Then it actually looks like this. We'll just fetch it here directly, okay? And this one. If we haven't written this one yet, we'll give it a tool. We'll consider it successful. That is, we detect it through some key-based method, whether this is ours whether it might be forged by someone else. A forged one, we consider it successful. Then we will make a cross-server judgment here. If it is successful, we will proceed with the following. If it fails, then it's very simple. It proves that this thing is fake. It might not necessarily be fake. It could be caused by version inconsistency or other reasons. At this point, we just need to modify our data. Our response, we will keep it as default. We will change this result type to this XG. We give it a, we can see, actually here, give it a detection of server-side data. Parsing failed. That is, it considers your thing to be invalid. We can just write one. You can see. This part is that parsing your request failed. It's not a data failure yet. It means your request itself is invalid. Then that's it. We have handled it. After handling, then this idea is also very simple. We need to convert this enumeration into this payment string, right? And then regarding this enumeration, actually we use reflection to convert it into this payment string. Okay, convert this enumeration to a string, and then we need, because the string, we need to print it later. This is for internal printing. And at this point, we extract a JSON double of this cell response. We convert it through this JSON serialization conversion. We need to include the header file. We let it include many header files. First of all, we definitely put a header file for this convite direction. Check again. Okay, then here, we take this struct, the struct we declared earlier. This is our first level data. Then we serialize this JSON here. Then we can directly send this JSON back. Replace this part, because we also have 8zone076. Just replace this part directly. Okay, then this enum should be placed here. This enum is mainly placed here. We just do a log record. What was done this time? What kind of result did it produce? So, regarding this enum, we can just place it like this. Put it here. No problem. But I prefer to put it here. We can just use this data directly later. Okay, so this completes one interaction. That is, if this interaction verification shows the request is invalid or the version is incorrect, we will have it return at this point. Then, at this point, we need to start parsing our actual request. So when parsing the actual request, we need to write it like this to convert it into an encoded format, because it is a body. You will find that this body is UEC. So you need to transcode it yourself. Therefore, through this method, there are some headers here, keyopen, but these parameters are what we extract from the URL. Sometimes people write parameters on the URL, or write them on the header. You can retrieve them through this method. You can take a look at this yourself. Just study it yourself. Then, in our case here, after we get it, we need to prepare. We need to prepare a struct. This struct is the struct for this secondary service. So this struct is here. It might be, should take a look. This should be the data for this primary service. It should be this primary service data. Let's first take the data of this primary service, signify it. That is, serialize this JSON into a sequence. Then we determine whether this saving can be parsed successfully. It is quite conceivable that this saving might fail because someone might have written it incorrectly, or the version has changed. The definition of that saving is different. It might fail. If it fails, we assign an enum here. It is called parsing this JSON failed. That is parsing the client's request. It should be called parsing the client's request failed. Yeah. We also call this a failure. It might not be called a validity failure. It is simply a data failure. This failure is about parsing its data. Failed to parse the secondary data. Then next we need to perform a distribution. Why do we need to perform a distribution here? Because we have a lot of them. or login and registration. If we log in and register, we can do it on the interface. We can perform distribution on this HTTP configuration. We can also use one interface. Just access this one interface. Through the enumeration of the primary data inside it, it doesn't perform distribution either. That is also completely fine. So let's write the distribution interface first. As for the distribution interface, we can just write it like this. We wrote it here. It's about handling this structure. And as for the structure, it actually uses our simple. It distributes the data after our simple. And this out is a return value. That is, we need to prepare a value to make a modification. This way, it will output the result. Okay, right. Pay attention to this in and out. Then we can call it here. So here we make a distribution call. This is our data, right? And next is the result we need to return. Should be this. Take a look. Yes, it should be. It should be this one. This is equivalent to it fills this data into this. This is the first level data of the request. This is the first level data of the response. Actually, after the distribution is complete, we can get this enum. This enum is the enum inside the. It must have gone through this kind of fidelity processing. We can use it here. Yes, good. Okay, simple request type. Let's look at the enum here. Request type should be its enum. I wrote it wrong. This part is mainly for recording. Which request we are making and what is being requested. Yes. Okay. So actually at this point, the framework for this thing is already distributing data. The framework is already done. So after entering, we first check the validity. If it is invalid, we just kill it directly. That is, there might be some whitelists or token settings. If it is valid, we check again whether this data can be parsed according to our current protocol. If it cannot be parsed, we consider it invalid and skip it. If it can be parsed, we pass in the data to be parsed. Then, for the data to be returned, we output it again. Then, after we finish outputting it, we record it, and that's it. Since it records the request here, we will move it up here, like this. This makes it a bit more reasonable, and this part is essentially completed. Record the final completion information. Then next, we will proceed with the distribution work. For this distribution, we need a switch. At this point, since we have successfully parsed the first level data, what kind of request type it actually is? Let's do it here. It doesn't seem to pop up on its own. Let's paste it. See if it can pop up on its own. Hey, look, it didn't pop up. So why didn't it pop up? Maybe it just didn't recognize it. If it didn't recognize it, it's fine. We'll just write it ourselves. Actually, when writing this, we can just give it a default one first. If this fails, we'll let it create a type. This is the result type. This is the result. We'll set it equal to this number, equal to this unknown request type. It's just that I don't know what you're requesting. It's possible we haven't implemented it yet for an unknown request. In other cases, currently, we mainly have this kind of request. As for this request, it is called this. No, it's not this request type. It's called this request type. So here we have a case. It is a request for version verification. Note that the break in this section must not be missed. Then we write the method for its specific distribution here. We call it handle checkivation. Handle checkivation. That works for us. Then this, just write it here. And the structure it returns is this. Okay. Then this section actually does not need the static identifier. Okay. Then here, we call this method. We pass this data in. and this data is at this position, then we directly let the thing here equal the value it returns. Then we actually process the request data right here. Actually, how do we handle this? At this point, we are processing the secondary data here. So we need to prepare such a struct. What is this struct? It is the secondary data we sent over. So we need to convert the connection back for heading. Then let's first prepare out. This is the response data. Yes, so actually the response data here is this, because you need to return this thing back in the end. You need to return this response back. Let's prepare it first. We can just put it here. Then we prepare the first data. We start parsing. Then for the response, we first need to change the data type to this check version, because we know it is requesting version information. Then we make a judgment here. If the parsing fails, then we consider this a parsing data failure. That is, parsing the second phase request data failed. Then just return directly. Then because we have default values here, can you see that? This struct actually has default values. Right, the default is false only when it succeeds. Will we change it to success? Okay. Then next we need to perform the actual version verification. First of all, how do we verify this version? We need to make an external judgment. That is, we need to call this judgment to determine whether this version is a version number. That is, it is not empty. And after it succeeds, we let it compare with our equip manage. That is, it compares with it. Our tool such. Is the version consistent? Okay. If this part succeeds, we consider this part successful. We take this respond B 应否批胜 and treat it as a success. Then for the result here, we need to use this success. Okay. And if this part fails, it proves the version is inconsistent. We return an error. Just return the error version. Okay. So our server side is actually already done. The interaction is fully completed. Okay. Okay, let's take a look at this lesson. So after the server-side interaction is done, this process is really quite complex, very complex, this process. So at this point, let's go ahead and walk through the client-side process for everyone as well. Okay, let's go back to the client side here. Let's take a look here. So here we are, going back to our response here. So here we will do some processing. We might need to wait until next class to show you this processing. Okay. We will test it for you in the next class and link together the previous stages because it's quite complex.